Welcome back, grade 11 students, to lesson 3 of this unit. In this lesson, we're going to cover while loops and switch cases, two new types of looping strategies that will allow us to process information in a way similar to if and for loops, but they just have particular situations where they're the better choice for, and so we're going to try and figure out when they might benefit us and how we're going to use it in this section of application programming. To begin with, I note here that we're on lesson 3. I haven't changed the name of my class yet for lesson 3. Let's do that now. You're going to notice something though, that if you try to just change the name here, it's going to bark at you. This should be declared in a file named lesson3.java. You need to change the name of the file here. The better place to do this is to change the name of the file first and everything will follow. So I'm going to just right click on my file, go down to refactor, and rename my file to lesson 3. And then I'm going to hit refactor, and it's going to change the information everywhere it needs to so that everything's consistent. Try to always change big picture things like this, like that, from your projects list here. Then everything will follow automatically. Awesome, so lesson 3 here. So we're going to begin by talking about this while loop. Think about the word while in English. As long as, well, if I say while class isn't finished, we're going to be doing some learning or some work. Once that bell rings, then I'll get off your case about working because no longer it's not my responsibility to watch you anymore. But while class is in session, you better be working, right? As long as we're in that range of things. So while we define inside of our brackets kind of the circumstance that this information will run in, and then in our squiggly brackets below, we define what information will run while all this is ongoing. Let me show you an example of this. You can kind of see a sneak peek at my output. I tested it a minute ago. I'm going to say, well, first, let's define a new number, int num. I'm just going to initialize it to start at 0. And I'm going to say while num does not equal 5. So as long as num is not equal to 5, then let's print out not there yet. Let's think about what will happen when I run this program. Num is equal to 0. While num isn't equal 5, is num equal to 5 initially? It's not. I'm going to print out not there yet. When I run this, you'll see that my program is printing out not there yet over and over and over. This will actually print forever if I let it, because there's nothing changing the value of num, so there's nothing that would ever make it stop. Num is always not 5, and so it's going to get stuck on this thing and loop infinitely. I'm going to stop my program from doing this down here where it's running. I'm going to hit on this little X and stop it. It ran for 25 seconds, printed out not there yet, who knows how many times. So I need to do something in here that will maybe change the value of num so I eventually can break out of this while loop. And we need to be very careful in while loops that we always have some way of breaking out of them. So here's how I'm going to do this. Whenever I run through this, I want to print out what num am I at. The num is, remember how I do this, concatenation. I'm just going to add on the num is num. And let's just make this a proper sentence by adding the period at the end there. All right, so if I run it now, we'll see not there yet, the num is 0. It's going to loop infinitely. Oops. So I'm going to simply just make num increase by 1 each time. Can you predict what the output will be? Let's take a peek. Not there yet, the num is 0. 1, 2, 3, 4. And when it reached 5, what happened? The program ended because when num was 5, it no longer ran the information in our while loop. So I've set up a scenario where this while loop can actually be terminated, which is wonderful. Can you predict what will happen if I change this to 10? Well, 0 through 9, when it reached 10, it ended. I can do this for all sorts of different scenarios, processing through things really quickly. It processed through counting to 100 or 99 because I limited it at the point of 100 just like that. So while allows for rapid processing of things in repeated ways, and as long as I don't get to an infinite loop, our program should be the better for it. So that's a while loop, and we can use this in different scenarios. Let's take a look at one here. Maybe we want to do get some user input. Let's use our other type of input type where we have the pop-up box. So I'm just going to remove this code here. We're going to change what our while says here, and I'm going to make a string. Oops, not an I string, not an Apple string. String input. And one thing that I need to do, otherwise NetBeans is going to be mad at me, I need to initialize it. I don't want it to have any information yet, so what I'm going to do is I'm just going to put quotation mark, nothing in between. It's an empty string. There's no data yet, but I want it to kind of exist, and so be ready for data later on. So what I'm going to say is while input does not equal end. There's a problem here, though, is that it says comparing strings using equals or not equals. Strings are not primitives. Here's the main thing we need to remember about primitives. Int, lowercase. Double, lowercase. Boolean, lowercase. All of these lowercase things, we call those primitives. Am I spelling primitive right? Primitive. These are things like int, double, boolean. Let's make it clear here. And these things we can compare directly with these equals comparators. But string is an object. Let's make it all capital. Meaning that we have to compare it in a bit more of a fancy way. And objects, based off of classes, have methods. How do we access a method? With a dot, and you'll see here, bam, I see the list of all the different methods I can run. And here's one that I want you to know, equals. This is how we compare a string to another. While input equals, and then in it, in args, we put the word. So what I'm going to say for this while loop is the not value. While our input does not equal end. Basically, as long as our input isn't end, I want this loop to continue. So here's what I'm going to do. I'm going to say input equals get input, and I'm going to say type in a word. I'm using that method I created to make this a little bit quicker, the JOption pane show input dialog, stuff that we learned in our previous lesson. Go back and review it if you forget how that all works. But I'm gathering information about input that I'm going to type in. And what I'm going to have happen here is that it's going to keep on asking me for a word over and over again until I type in the word end. Let's run this and see what happens here. Type in a word. Yes. No. Maybe. Go. End. And my program finishes. So once I typed in this particular statement, my program finished. Now, maybe I could add another layer to this. Let's think about our Boolean logic. I'm going to put in here, or our input is finish. Maybe I want to give my user options for how they can exit out of something here. If I type in hello, type in numbers, type in random whatever, doesn't matter. But if I type in finish, did I spell it wrong? Can you figure out why finish would not be ending this while loop right now? Great review of Boolean logic. I'm going to cancel this for now, which will end my program. Let's think. As long as it's not end or finish, keep on running. Could it ever be end and finish at the same time? What happens if I put an end? Program ends here. Program ends here. While we don't have this and we don't have this. If one of these two things happens, then it's going to terminate the while loop because these need to both kind of be gatekeepers of what's going on here. So I need to make sure I use the right Boolean operator in this place here to be able to manage this while loop properly. So there's a couple examples, while loop built around ints, while loop built around strings, and you can surround your code in all sorts of these things, and I'll be showing you in an upcoming tutorial a way that we can use this to ensure a better user experience for different types of things. So there's your while loops. Now let's take a look at our switch cases here. So I'm just going to erase the code that I have here. You can always back it up if you need to see this once again. And to set this next section up, I'm going to just create a string or an int called input and a string called output that I'm just going to initialize like so. And what I'm going to be doing here is I'm going to be printing out different messages depending on the different user inputs. The loop will continue to get user input until 5 is selected. That's what I want to do here. But I wanted to actually print out some more information here. So first of all, I'm going to say, well, input is not equal 5. Okay, so that's the condition for my while loop. And as long as that's happening, what I want to have happen is I want to print out to the user to type in a number from 1 to 5. And I want to use my scanner again here. So I'm going to say my input equals scan dot, hang on, scan's not working. What's going on here? Well, in this program, I haven't actually imported my scanner yet. So let's do that again really quick. I'm going to call it scan equals a new scanner based on system.in. Scanner isn't imported yet. Let's click on the side, import it up here. Great. So now I can actually reference the methods of scanner. And so in this case, I want to get an integer. My next int is up here, my quick reference list. I'm going to get the next int for my input. And so now I've been able to gather some information from my user. But now I want it to, well, first of all, let's take a look at our program and see how it runs. Type in a number from 1 to 5. Type in 1, 3, 4. It keeps on looping whatever I type in. Now, if I type in a letter, the program's going to break, so let's be careful about that. But when I type in 5, my program ends because that's what the while loop is dealing with. So this is what we've covered already, the breakpoint for a while loop being processed properly. But I'm going to add something new in here called the switch case strategy. I'll provide you some notes so you can read about this a little bit more. We can think of this as kind of a refined if chain. And here's how it works. I call it a switch. And then inside of the brackets, I tell it what variable I want to look at. And I want to look at the input that I'm getting. So I'm going to take a look at input. And what am I going to do? Well, I'm going to tell Java for each value, each case of input that I come across, I want it to do something different. So, for example, let's say case 1. This means that if the value of input is 1, so if the user types in 1, then what do I want to do? Well, in this case, I'm going to have Java change output. Cool. You chose number 1. Now, there's one thing that we have to do in our switches. After each case, we have to say break. What that does is it makes it clear that this is the end of what the functionality of this case is. So I can type in more functionality here. I could change output's value again, or I can say that input equals something different. Maybe I set it back to 0 afterwards. I can do lots of other code, but the break is like, okay, that's the end of that case. So I just have to add break in there. What if the user types in 2? Let's say you chose number 2. Break. Case 3, you chose number 3. Not the most fascinating program, but that's okay for now. Let's just wrap up these different scenarios. But now case 5 is the one where a loop breaks, and I want to communicate that to my user. So I'm going to say, oops, equals, you chose poorly, game over. This isn't really much of a game, but let's just say it was. Then that would be the output for that case. And what about all the other numbers? Oops. All of our other values, well, actually, we'll deal with this later. We'll keep it like this for now. So in this case, what's going to happen is that whenever I have an input value from my user, the switch is going to go, okay, for whatever value I got, is it one of these cases? If it is, then print out or assign, in this case, the information associated with that particular scenario. And then outside of the switch, so remember these curly brackets are just about the case information. Outside of it, what I'm going to do is I'm going to print out whatever the output was. So let's take a look at this here. Type in the number 1, you chose number 1. 2, you chose number 2. 3, you chose number 3. 4, you chose number 4. 6 is going to repeat the scenario that I had previously. Interesting. And if I chose number 5, you chose poorly, game over. So, oops. What we saw here is our different cases being accessed. I have some different scenarios I can code in a nice organized way. Now, what we can do to get out of this weird behavior, if I type something outside of what I program, I was trying to show you here before, we're used to writing else in our if statements, but we have a bit of a different term in our switch cases here. Else is not going to be recognized. You'll see that Java is a bit mad at me for it. But we do want to deal with any scenarios outside of our cases, otherwise we get the strange results I wanted you to see down here. We call this default. And default is going to be the behavior that we wanted to have in any other case. It's basically an else statement. And in this case, I don't want to deal with this number. Why don't we just make that the message? And of course, oops, we need to make this break. And so now, when we run our program, we can deal with all those scenarios here. If I type in 0, I don't want to deal with this number. 3, chose the number 3. 8, I don't want to deal with this number. 5, you chose poorly. Game over. So I've given the user the ability to input again and again and again different guesses of numbers or different inputs for some purpose, not really defined here yet. And then I've defined in a nice organized way what are all the options I want clear responses to. And then what are all the other responses that are possible. And by using the switch case functionality, it's a nice organized way of dealing with lots of options that can be output. So in this section, we have our inputs. We're telling the user what to input, then we're gathering the input, and then we're outputting to them the result of whatever happens based off of their input. And in our while loop, whenever we reach the scenario that we've defined in this terminating expression, then the while loop is going to finish and our program will end, assuming there's nothing else after it. All right, so there's a couple new tools you can add into your repertoire. I expect you to be seeing you using both while loops and switch cases in your work in this section. And I'll show you some more examples of these in our final few tutorials for this section. A bit of notes to take a peek at just for some written information about these strategies. Great tools to use in your own coding. See you in the next tutorial.